There are two ways of creating a heap. One is the way that I showed you previously, which is every time we put in a new node, we then reheap. This is another way. And the reason that we have these two ways is because it depends upon the circumstances, the way that we want to create our heap. So in this method, we always have a complete tree. So I've put here the numbers that we're going to put into our tree. And I show here how we keep on creating a complete tree. So after we put in the roots, the only place we can put something to make it complete is its left child, and then the right child, etc. And ultimately, we will get to this situation here. Well, you can see it's complete, but it is not a heap. We can put this, we can reference this as an array. And when we do that, we say, okay, let's take the root as index 0, and then we'll go index 1, the left child, index 2 is the right child, so left and right child, 3, 4, 5, 6, and 7. So keep on going across the levels, 0, 1, 2, 3, 4, 5, 6, 7. And those are the indices. And that's how I make a single array out of my tree. And the reason I do this is because that some languages don't have nodes and don't enable you to make trees, so we can keep it as an array. So now I have it either like this or like this, it doesn't matter, it's the same structure, and I want to make it into a heap. So I look at the leaves. The leaves are already heaps, mini heaps, because they don't have any children, and therefore the node itself, the leaf itself, is less than each child. This is a min heap, so less than each child, because the children are not there, it doesn't have any. And then I move up. So this 19 is actually, it's okay, but because it's less than the 45. But when I move up, I got a 23, which is bigger than the 19. It's actually less than the 50, so I have to swap 19 with 23 and I get this situation. And similarly, moving up here, 14 and 12 were fine, but when I got to the 30, 30 was bigger than 14 and 12. I'm going to swap it with its smallest child. I'm going to swap the 12 and the 30, and that puts that in good shape. So this subtree is fine, this subtree is fine, but now I got a 40, which is all out of whack. So I have to swap the 40 with its smallest child. So the 12 goes up, the 40 comes down, but then the 40 has to be swapped with its smallest child, which was the 14, and we get this. So this is our min heap. Using the same numbers that we did in the previous video, and if you go back and check, you will see that they are both heaps. They both have the same numbers, they just look different. The numbers are in different places. So it's possible to make the same shape, to keep it as a heap, meaning or a minimum heap, each parent is smaller than its children, and yet have the numbers in different locations. And then when I put this into an array, I get that. 12, 19, 14, 23, 50, etc. So when I have this array, which is this tree, I can figure out from the array So I can program this. I can figure out from the array which are the left and right children of any node. Because if I just pick a node, let's pick this one. This 19 is 0, 1, 2, so it's 1. Its left child is 0, 1, 2 is 3, and its right child is 4. 1's left child is 3. That's 2 times 1 plus 1. 2 ones are 2 plus 1 is 3. And its right child is 2 times 1 plus 2, 4. And if I use the same formula for this guy, the 14 is 0, 1, 2. Its left child is 2 times 2 plus 1, which is 5. And its right child is 2 times 2 plus 2, which is 6. So for any node at index k, its left child is 2k plus 1, and its right child is 2k plus 2. So we have an advantage that we can keep our heap as an array, and that's an advantage when we have a language that doesn't support nodes. We have a disadvantage because we know that when we have an array, we have to declare its size initially, and we have to have enough space to keep all our data in contiguous spaces in memory. We can't have something over here and then something someplace else. It all has to be in a line in memory. Well, we can get around that if our language supports increasing the size of an array, and some do. Java has array list. C++ has vectors. They can which can be resized. So we have a choice. We can keep it as a tree or we can keep it as an array.